Hello everyone. I would like to greet all the dear friends and companions of Pharmatalk. We are here with another educational video in the field of the pharmaceutical industry. This video is about the HPLC device, its principles of operation, and the arrangement of its various components, including the separation of detectors in HPLC. So, stay with me until the end of the video and join us to participate for free in an HPLC class. I would like to explain that we want to define chromatography at the beginning. What is the definition of chromatography? I will also discuss its applications later. In fact, if we want to have a complete and clear definition of chromatography, it is a method that separates compounds physically before we measure them. The separation is based on the affinity of the substances for the stationary phase and the mobile phase. Different stationary and mobile phases create varying affinities, which allows the substances to be separated from each other using this method. Subsequently, we identify the separated substances in chromatography using detectors. Therefore, chromatography is a method for the separation and quantification of samples. In the following, I will discuss the types of chromatography based on the mobile phase. The most well-known chromatography method is HPLC, high-performance liquid chromatography. HPLC is a liquid chromatography method, which means that the mobile phase we use must be a liquid. Another widely used method is gas chromatography. There are other methods as well, such as supercritical fluid chromatography, but the method we will discuss more in this class is liquid chromatography. Why should HPLC be used extensively, and what are the applications of this device? HPLC is a device that allows for simultaneous analysis and determination of the concentration of various substances. Additionally, liquid chromatography has a very high resolution and sensitivity. What does this mean? It means that it can detect very low concentrations of substances. For instance, if your concentration is at the level of ppm or, in some cases, ppb, the HPLC device can identify the substance. Furthermore, this device has very good repeatability, and you do not need to have large amounts of the sample, you can work with a small quantity of the substance. The preparation conditions are not very complicated, meaning that, for example, unlike gas chromatography, GC, there is no need for the sample to be evaporated. Most of the detectors in HPLC are non-destructive, meaning they do not destroy the substance being analyzed. The next discussion is about the application of HPLC devices. We want to know where they are used. I will mention a few main areas of application, and in each of them, I will provide some examples to help you become more familiar with it. In the pharmaceutical industry, HPLC is used for the analysis of antibiotics and cosmetic products. In the biochemical field, this device can be used to analyze amino acids, proteins, peptides, sugars, and carbohydrates, such as lactose. In food analysis, one of the most important applications of HPLC is the analysis of pesticide residues in food, such as mycotoxins, with the most significant mycotoxins being aflatoxins M1 and B1. The analysis of vitamins, fatty acids, and antibacterial compounds is also very common in the food sector. In addition to the mentioned applications, this instrument is also used in the analysis of chemical substances, environmental analyses, and in the clinical field for analyzing various compounds. In the following, we will discuss the most important components of the HPLC device. The first thing we will address is the arrangement of components in the HPLC system. The HPLC system has glass containers at the top, which hold the mobile phase. Depending on the nature of the pump, these containers can be either 2 or 4 in number, meaning that 4 mobile phase containers are placed on the HPLC device. After the mobile phase, the main component of the device is the high-pressure pump. This pump typically generates pressure in the range of around 4,000 psi to enable the mobile phase to flow through the column. Following the pump, there is an injector that introduces the sample into the HPLC system. After the injector, there is also a column oven that controls the temperature of the column. As you know, temperature is a significant factor in separation. In HPLC, maintaining a constant temperature is crucial to enhance the reproducibility of the results. However, the separation occurs in the chromatography process. And after the column, there is a detector responsible for identifying the separated compounds. After the sample passes through the HPLC device, what we receive as a product is something we call a chromatogram. A chromatogram contains information that we will discuss further. As you can see in the graph, the chromatogram is created over time, meaning that as time passes, the signal shown in the detector is recorded. This signal intensity is plotted against time in the chromatogram. There are several key items in the chromatogram that we would like to introduce to you. The first is the retention time, TR, which indicates the time interval from the injection to the exit of the sample as shown by the detector. In addition, the area under the peak and the height of the peak also represent the concentration of the substance in the analysis. The next important aspect of the HPLC system is the mechanism of separation of compounds within the device. We need to understand that the separation fundamentally occurs in the chromatography column, and it is based on the differences in the compounds, affinities for the stationary phase and the mobile phase. What this means is that, as you can see, there is a red compound and a blue compound. The red compound has a greater affinity for the mobile phase, while the blue compound has a greater affinity for the stationary phase. Initially, these two compounds are present together in the column, but as they move through the column, the blue compound moves more slowly, while the red compound moves more quickly. This difference in affinity for the mobile and stationary phases leads to the separation of these two compounds. As you can see in the chromatogram, the red compound elutes first, followed by the blue compound. In this way, chromatography allows us to separate these two compounds, achieving our goal of separation. In continuation, I will explain that the separation occurring in the column can have different characteristics depending on the stationary phase and the mobile phase. What does this mean? If the stationary phase present in the column is polar, meaning it is made of silica, and the mobile phase is nonpolar, it is common to use compounds like heptane or normal hexane in this case. Essentially, this type of chromatography is known as normal phase chromatography. Therefore, there will also be normal phase chromatography columns. If the column has a nonpolar stationary phase and a polar mobile phase, we refer to this as reverse phase chromatography. There are other types of chromatography as well, such as ion chromatography, size exclusion chromatography, and affinity chromatography. The applications of these two main types, especially the second one, which is reverse phase chromatography, are particularly significant. The types of stationary phases in reverse phase chromatography columns vary depending on the nature of the attached nonpolar phase. The most commonly used reverse phase chromatography column is the C18 column, also known as ODS, which is used for the separation of compounds. In terms of classification, these columns are referred to as L1. The second widely used reverse phase column is the C8 column. The stationary phase used in these columns is octylsilane. Other columns, such as C4, phenyl columns, and TMS columns, also have significant applications. The types of mobile phases used in reverse phase chromatography are primarily based on aqueous solvents, along with various buffers such as phosphate buffer and acetate buffer. Additionally, highly polar organic solvents like methanol and THF, tetrahydrofuran, are also used. One of the crucial factors that significantly impacts separation is the ratio of organic solvents to aqueous solvents. In addition to considering the ratio of the mobile phase used, there are two scenarios. If the mobile phase remains constant over time, we refer to this as isocratic elution. However, if the ratio of the mobile phase changes over time, such as variations in the components or changes in the buffer ratio, this is referred to as gradient elution. Each of these two methods has its own advantages and disadvantages. Generally, gradient systems are used when separation is difficult to achieve and adjustments in the mobile phase are necessary. On the other hand, isocratic elution offers a high level of convenience, as working with a single mobile phase allows for equilibrium to be established in a much shorter time. At the end, I will introduce the types of detectors used in the HPLC system. The visible detector has the most applications among detectors. It operates in a single wavelength mode, and some types of visible detectors also have the capability to operate in two wavelengths, meaning they can perform measurements at two different wavelengths. Another type of detector is the PDF detector, which has the ability to analyze different wavelengths, allowing us to obtain a complete visible spectrum for each retention time. These detectors can perform quantitative identification, and there is also the possibility of qualitative identification, helping us understand what substance is currently passing in front of the detector. Another widely used type is fluorescence detectors, which can detect concentrations at lower levels. Additionally, RI detectors and mass spectrometry detectors are very powerful and are used in HPLC systems. Thank you very much for watching this video. At Pharmatalks, we strive to share knowledge about the pharmaceutical industry, both in the quality control and quality assurance sectors. I really appreciate your support on this journey. If you have any comments or questions, please feel free to ask us in the comments section, and our colleagues will definitely get back to you as soon as possible. As I have mentioned several times, we are active on various platforms including Telegram, LinkedIn, Instagram,